Hello, Mr. Betts here. So I want to look at a few examples of how we might use the nth term test for divergence. Remember the question that we're going to be asking ourselves about particular series is, does the series converge or does it diverge? And the nth term test for divergence can answer one of those questions for us. It can give us one of them possibly. So what we have to keep in mind is the nth term test for divergence can only tell us if a series is going to diverge. If the nth term test doesn't apply, then we don't know if it's going to converge or diverge. So in this example, this is actually the harmonic series that I'm going to look at in a little bit more depth later. We want to know if this is going to diverge using the nth term test for divergence. So the first thing we're going to do is we're going to take a look at this limit right here. So we're looking at the limit as n approaches infinity of 1 over n. So looking at this limit here, as n gets really, really big, that's going to give us a denominator that's really, really big, and the terms are approaching 0. So this is the case where we actually have to be careful. We don't know, based on this answer, if the series converges or diverges. The only conclusion we can make is when this limit is not equal to 0. So if the terms do approach 0, it means that the series could converge, but it still might also diverge. So we cannot make a conclusion. In this example, we have another series. We want to look, it's same question, just different series. Let's look at this limit as n approaches infinity of the terms themselves. This series looks kind of similar, but this time as n approaches infinity, this term is going to approach 0, but we still have that 1 there, so the terms are going to approach 1. So essentially what that means is as n gets big, this series behaves like 1 plus 1 plus 1 plus 1 plus 1, infinity times. So essentially what's happening is at the end of the series, we're going to just add 1 on over and over and over again. Based on that nth term test for divergence, this is not equal to 0. And since the terms are not approaching 0, then we can say that the series diverges. Yay. Or maybe we're sad because it diverges, though. I don't know. Okay, next one. We want to look at the limit as n approaches infinity of the natural log of n over n plus 1. So as n approaches infinity here, n over n plus 1, that is going to approach 1 because we have the same degree on the top and the bottom. So essentially what's happening, if we plug in a big value for n, we might have 1,000,000 over 1,000,001. That's really close to 1. And as n gets bigger, that's going to get even closer to 1. So this is going to be approaching the natural log of 1. If you don't remember what the natural log of 1 is, it's okay. Let's say the natural log of 1 is some number k. If we rewrite this in exponential form, this e to the k is going to have to equal 1. So e to what power is 1? That would be 0. You might also deal with natural logs thinking of the graph of the natural log function that looks like this. It's the inverse of the exponential function. We've talked about inverse functions already. So the graph goes to the point at 1, 0, so that's going to approach 0. It's not important here, but this is approaching 1, but it's always going to be values that are less than 1, so it's approaching 1 from the left side, which means that the terms are going to be approaching 0, but they're going to be numbers that are slightly smaller than 0. It doesn't matter in this particular problem, but just a quick refresher on limits. So based on this answer, remember the nth term test for divergence only works if this limit is not equal to 0. It cannot tell us if a series converges or diverges when this limit is 0. So again, we cannot make a conclusion.